Hi everyone. In trigonometry, there are a number of angles that you're expected to be able to work with without using a calculator. In other words, you must be able to find out the ratios of these angles using a method different to using your calculator. The method that is commonly used to remember these angles is drawing special triangles. In this video, I'm going to show you where the special triangles come from. Then, in the video after this one, I'll show you how to use the special triangles. The special angles I'm going to discuss in this video are 45, 30 and 60, and 0 and 90. I'm going to develop special triangles for each of these sets of angles. Here I've shown the special triangle for 45 degrees and the special triangle for 30 and 60 degrees, which should make more sense to you by the end of this video. Let's start with a special triangle for 45 degrees. So I'm going to start by constructing a right-angled triangle. Now, if one of the angles is 45 degrees, what will the other angle be? Surely it will also be 45 degrees, because the angles in a triangle add up to 180. The first angle is already 90, so I must be left with 45 and 45. Now, I'm sure you can see that this triangle will be isosceles, because the sides opposite the equal angles will be equal. So let's decide on a value to make one side, and I'm going to choose 1 as each side length. Now, how large will the hypotenuse be? Let's work that out. Hypotenuse squared will be 1 squared plus 1 squared because of Pythagoras. So 1 squared plus 1 squared is 2. That's the hypotenuse squared. Therefore, the hypotenuse is the square root of 2. And I'm going to leave that in surd form. And that is the special triangle for 45 degrees. Let's see how to apply it. If I have sine of 45 degrees, using this triangle, sine of 45 will be opposite over hypotenuse. In other words, 1 out of root 2. And cos of 45 is adjacent out of hypotenuse, 1 out of root 2. And tan of 45 is opposite out of adjacent, 1 out of 1, which gives me 1. Do you notice that sine of 45 and cos of 45 are equal, but tan of 45 is different? To create the special triangle for 30 and 60 degrees, I'm going to start with an equilateral triangle. And I'm sure you know in an equilateral triangle, all the sides are equal, and each angle is 60 degrees. Now, the way I'm going to get the 30 degrees is by bisecting my triangle. Now, since I started with an equilateral triangle, I can be sure that the line I use to bisect the triangle will cut the other side in half. Also, it will be perpendicular to that third side. Furthermore, the angle created will now be 30 degrees because it's half of 60. Now we need to add in side lengths. If I was to make each side 1, the side at the bottom would be halved and I'd get half of each length. Now I don't really want to work with fractions, so let's rather work with 2, 2, 1, and 1. And I'll remove these other values. Since the triangles are similar, I could have any enlargement or reduction of that situation. Now, when I'm working with trig ratios, I normally use right angles. So I'm only going to use one of the right angle triangles. These two triangles are congruent. So let's just use the one on the left. It doesn't matter. And what I'm missing is the height. So according to the theorem of Pythagoras, I must add the squares of the two sides. So that will be 1 squared plus my height squared. That will equal to my hypotenuse squared. So let's calculate what the height squared is. It will be height squared. 2 squared is 4 minus 1. So my height squared is 3, which means my height will be the square root of 3 units. Now the triangle that we're interested in is just the right angled triangle, so we can ignore the other half of the equilateral triangle. Let's look at how the ratios come from here. So if I'm looking for sine of 30, there's 30. This will be the opposite, this will be adjacent, and 2 will be the hypotenuse. So Sine of 30 will be opposite over hypotenuse, a half. Cos of 30 degrees will be adjacent out of hypotenuse, root 3 out of 2. And tan of 30 will be opposite out of adjacent, 1 out of root 3. Now let's look at the ratios for 60 degrees. Sine of 60, if I'm using 60, I now have a different opposite side. So opposite will be root 3, out of the hypotenuse stays the same. Cos of 60 will be adjacent out of hypotenuse, and tan of 60 will be opposite root 3 out of adjacent, which is 1. In other words, root 3. And that's how you use the 30 and 60 special triangle. Now let's discuss what happens at 0 and 90 degrees. I've made a little animation to help you understand. Here I have a hypotenuse of 1 unit. If the angle I'm interested in is 45, then I'll have an isosceles triangle, and these two values will be the same, and 0.71 is the same as root 2. Now when I start the animation, look carefully at what happens to the adjacent side and the opposite side as the angle changes. Can you see, as the angle gets smaller, the opposite side gets smaller? So my value for sine will be a small value over the hypotenuse, a small value. And my value for cos will be the adjacent side, a larger side, over the hypotenuse, and it will start approaching 1. Let's consider what happens as my angle gets larger. Can you see that as my angle gets larger, my opposite side approaches 1, and therefore the sine ratio will increase in size, but the cos ratio will decrease in size. Now what happens if my angle was 0? If my angle is 0, then my adjacent and my hypotenuse are both 1, and my opposite side is 0. And what would happen if my angle was 90 degrees? My opposite side would become larger and larger and larger until it reaches 1, and my adjacent side would, in theory, be 0. Let's look at these two situations separately. For 0 degrees, my hypotenuse will be 1. My opposite side is 0, and my adjacent side is 1. For 90 degrees, my hypotenuse is still 1, but now my opposite side is 1, and my adjacent side is 0. So if I think of sine of 0 degrees, that will be opposite out of hypotenuse, 0 out of 1, which is 0. Cos of 0 degrees will be adjacent out of hypotenuse, which is 1, and tan of 0 degrees will be opposite out of adjacent, which is 0. For 90 degrees, sine of 90 is equal to opposite out of hypotenuse, which is 1. Cos of 90 is adjacent out of hypotenuse, which is 0. And tan of 90 is an interesting one. Tan of 90 will be opposite out of it adjacent, and I'm not allowed to divide by 0, so this is undefined. There are many different ways to remember the ratios for 0 and 90. Some people use a graph, some people use the sketch I showed in the previous slide, and others sneakily use their calculator because you can't really tell if they use their calculator. But another way to work with 0 and 90 is by remembering an impossible triangle, and I'll explain why it's impossible now. So one of the angles will be 0. Now, like before, I'm going to make my hypotenuse 1. Now surely if my angle is 0, the opposite side must be 0. So I'm left with 90 degrees, and if that's 90, this would be 1. And then you can use this triangle to work out the ratios for 90 and 1. It works exactly the same as the previous sketch. So in summary, let's look at the 3 triangles, or 2 triangles and 1 optional triangle, to remember your special angles. The first triangle we discussed was for 45 degrees. My adjacent and my opposite are 1, and the hypotenuse is root 2. The second triangle is for 60 and 30 degrees. Now the hypotenuse in this triangle is 2, and I'm left with 1 and root 3. Now 1 is larger than root 3, so it will go opposite the side of 60, and root 3 is the smallest, so it will be opposite the smallest angle. And the last triangle, which is optional to use, is the triangle to remember 0 and 90. So my hypotenuse is 1, the side opposite the angle 0 is 0, and the side opposite the angle of 90 is 1. It's really helpful to learn the first 2 triangles off by heart. And whenever you get trig questions that involve 30, 60, or 45, to draw the triangles down and use them to help you calculate those ratios. In the next video, I'll give you examples of questions where you'd use these special triangles.